Hello, in this video we are going to discuss about the transfer characteristics of transducer. As we studied earlier, the transfer characteristics of transducer depends upon three elements. First one is transfer function, second one is error, and third one is response of transducer to environmental influence. Now coming to the transfer function. Transfer function of a transducer defines the relationship between input quantity and output, and it is always a function of input. That is, the transfer function is output Q0 is equal to f of Q1. That is, output is equal to function of input. So now Q0 and Q1 are output and input respectively. So we can say that the transfer function is the relationship between input and output quantity. Now coming to the second one, sensitivity. Sensitivity of a transducer is defined as the differential coefficient, that is S is equal to dQ0 by dQi. The sensitivity of a transducer is not constant but depends upon the input quantity Qi. In some cases, the relationship between input and output is linear. In that case, the sensitivity remains constant over the entire range. And next one is scale factor. The scale factor is defined as the inverse of sensitivity, that is 1 by S. That is equal to dQ0 by dQ1. The scale factor decides the transfer characteristics of transducer. Whenever we are selecting a transducer, we have to keep in mind what is the relationship between input and output quantity. These functions, transfer function, sensitivity, scale factor, they decide the transfer characteristics of transducer. When we are selecting a transducer, we have to keep in mind that what is the relationship between input and output quantity, or we can say that we should know the transfer function of a transducer. Now coming to the second factor, it is error. In many situations, the input and output relationship is given by Q0 is equal to a function of Qi. If any departure from the above relationship, it results in error. For example, if we apply a input voltage, that is, we are expecting a output voltage Q0. But in practice, an output Q0 dash is obtained, then the error of the instrument is E is equal to Q0 dash minus Q1. Now coming to an example, if the measurement system gives a temperature reading 25 degree, when the actual input is 24 degree, then the error is plus 1 degree. And if the temperature is 26 degree, then error would be minus 1 degree. That is, error is equal to measured value minus true value. So error is defined as it is the difference between the result of measurement system and the true value of the quantity. Now, the errors are classified into mainly three types. First one is scale error, second one is dynamic error, and third one is error on account of noise and drift. Now coming to the first error, that is scale error. That is, scale means the part which is giving the relationship between input and output. That is, how the output is changing with the input. The scale errors are mainly four types. First one is zero error, second one is sensitivity error, third one is non-conformity error, and fourth one is hysteresis error. So coming to zero error, in this case, output deviates from the input from the correct value by a constant factor all over the entire range of transducer. Over the entire range of instrument, it is a constant, so it is called zero error. Here, the output deviates from the input over the entire range of the transducer. So the output is deviate from the input, or we can say that the output deviates from the correct value by a constant factor. Now coming to the graph. So this is the graph plotted between output and input. The dotted line is called the ideal curve. and the straight line is called the practical that we obtain value. And the difference between ideal and practical is called error. Now, in this graph, we can see that the error is constant the entire range of transducer. And this output is deviate from the input from a constant factor. Now, coming to an example, if the scale of the instrument while standing a measurement is greater than 0, but ideally it must be in 0. If it is not at the point of 0, it may be 0.04 or 0.6 value greater than 0. This constant error is present all over the entire value. If the actual value is 1, then we will get 1.6. If the actual value is 2, then it will get 2.6. That is the constant value is present all over the instrument. So this is called zero error. Now coming to the sensitivity error. Sensitivity error occurs where the observed output deviates from the correct value by a constant value. First, we have discussed about zero error. In zero error, a constant factor is present in all over the value. Now, in sensitivity error, the output is deviating from the actual value from the correct value, but not any constant value. There will be a ratio or multiplication factor in it. As the input is increases, the error is also increasing in it. But in zero error, the error is constant all over the range. That is the difference between zero and sensitivity error. The observed output deviates from the correct value by a constant value. So, at the lower limit, input value error is small, and in the higher value, it is high. Suppose the ideal output is Q0 and the practical output that we get is K into Q0. And over the entire range of transducer where the K is a constant factor that is multiplied by the output. Now coming to the graph, the dotted line is ideal and the straight line is practical value. From this graph, we can know that for lower limit value, our error is negligible. But in higher value, it is high. That is, the error is increasing in their range of the instrument. Now coming to the non-conformity error, here the experimentally obtained transfer function is deviate from the theoretical transfer function for almost every input. Special case of theoretical linear relationship between the input and output characteristics. This error is called non-linearity or non-linear distortion. Now coming to the graph, this is the dotted line is ideal value, but the practical value is deviating all over the entire time of the output. There is no constant factor in it. This is called non-linearity, non-conformity error. Now in hysteresis, all transducers have the effects of hysteresis. The output of the transducers not only depend on the input quantity, but also depends on the different output is obtained when the same value is applied to it. That is, when we are increasing the input, we get an output. At the same time, if we are decreasing the input, we have to get the same output, but it is not the exact same value as we obtain. There is a difference between output and two output. Suppose if we increase the input value from 0 to 50, we will get an output, and if you draw a graph, we get a curve. But now, if we are decreasing the value from 50 to 0, the full scale range, the lower range value, we are not getting the same value. That is called hysteresis. For increasing value, we will getting a value, and for decreasing value, we get another value or different output. It occurs when the output of the transducer is not only depend on the input quantity but also depends on the input quantity of previously applied init. A different output is obtained when the same value of the input quantity and when it is decreasing or increasing. Now coming to the graph, so here if we increasing our value from 0 to 50, we will get a curve just like that. At the same time, if we are decreasing the value from 50 to 0, we have to get actually the same value. But in practical, it is another curve. And this deviation is called hysteresis and the curve is called hysteresis curve. So now coming to the scale error. That is, scale means the part in which giving the relationship between input and output. So we have concluded that there are mainly 4 types of errors. First one is zero error. Second one is sensitivity error or non-conformity error. And fourth one is hysteresis error. In the case of zero error, the error is constant all over the entire range of the measurement system. That is, in the difference between ideal and output curve, there will be a constant value that we get. And in the case of sensitivity error, for the lower value of input, we get a lower error. And for the higher value of input, we will get a higher level. So that is, if we increasing the value, input value, at the same time the output error is also increasing with respect to output. That is, a multiplication factor is present in sensitivity error. Now coming to the non-conformity error, here the actual value is just like that, but practical value, each and every time the practical value is deviating from the ideal value. So if we select the transfer function of each point, we get different transfer function at different value of input and output. This type of error is called non-conformity error. But in hysteresis error, if we are increasing the value from 0 to 50, we get a curve, actual curve, and if we are decreasing the same value from 50 to 0, we have to get the same value, but it is not possible in transducer. The decreasing value, we get another curve. So the deviation of input and output curve, so that is increasing and decreasing value of curve, is called hysteresis error, and the curve is called hysteresis curve. So these are the main scale errors in transducer. Thank you.